Hello everybody, welcome to my channel Keep Calm and Love Maths. So today we will discuss about the question number 7 and 8 from the book A Classbook of Mathematics. So the first question is, so that if f is a function from closed open interval 0 to infinity to the interval minus 5 to infinity, and it is defined as f of x equal 9x square plus 6x minus 5 is invertible, and find f inverse of x. So we have to show that this function is invertible, as well as we need to find f inverse also. So we know that to show the invertible of a function, we can apply the definition of invertible function as well as theorem number 1. So here the function is given as f of x equal 9x square plus 6x minus 5. This is the function we are given here. So first of all, we need to check whether this function is invertible or not. For that, we can show that this function is bijective. That means the function is both 1, 1 as well as 1, 2. If we can show the function as a bijective map, then we can directly say that this function is an invertible function. So to show onto of a function, of a function, to show how a function is 1, 1, first of all, let us take two elements in the domain. Let x1 and x2 belongs to closed open interval 0 to infinity. Then we take f of x1 equal f of x2. Then, by definition of this function, this f of x1 will be 9 into x1 square plus 6 x1 minus 5. Similarly, f of x2 will be 9x2 square plus 6x2 minus 5. So if we simplify this, we get this. Here minus 5 cancels out. The remaining are 9x1 square. This, if we take it in left hand side, then it becomes negative. So 9x1 square minus 9x2 square plus 6x1 minus 6x2. Now we take 9 as common. Then 9 into bracket x1 square minus x2 square plus 6 into x1 minus x2. So if we know that a square minus b square is equal a plus b into a minus b. So here it is x1 square minus x2 square. If we simplify it, then we get x1 minus x2, and the other one x1 plus x2. So this is. Now if we see the two terms here, there is a common. So it is x1 minus x2. Again, we take x1 minus x2 as common and take it outside. Then we will get this x1 minus x2 whole bracket 9 into x1 plus x2 plus 6. Now either this part will be 0 or this will be 0. or 9 into x1 plus x2 plus 6 equals 0. Finally, x1 equal x2. Here we get x1 equal x2, but there is another part, 9 into x1 plus x2 plus 6 equals 0. So we see here 9 into x1 plus x2. We have taken two elements x1 and x2 in the domain close open interval 0 to infinity. So these two numbers are positive. 9 and 6 are also a positive number. So 9 into x1 plus x2 plus 6, this cannot be 0. It is always greater than 0 or a positive number. So this cannot be 0. This is not possible. So this is not equal to 0. So we have left only x1 equal x2. Whether we have taken that x1 and x2 are two elements in the domain 0 to infinity, then we take f of x1 equal f of x2, then we get x1 equal x2. That means this function is 1, 1. So to show that this function is bijective, our one thing is done. Next, we have to show that this function f is onto also. Now, to show onto of this function, let us take that y equal fx. Then y will be equal to 9x squared plus 6x minus 5. So I will here express this x in terms of y. Then we will get, first of all, we simplify this expression. Since here there is a square term x squared, so I will expand or simplify it in the form of a minus b whole square or a plus b whole square. Here 9x square means 3x whole square plus 6x can be written as 2 into 3x into 1, right? A square plus 2ab plus b square. Since I have taken 1 as b, so plus b square. But here minus 5 is already here. So in this expression, the extra term is 1 square. So we cannot take it as n extra because 9x square plus 6x minus 5 is not equal to this expression, but we have equal expressions. Therefore, this should be removed. So I will add another minus 1 square term such that 1 square minus 1 square cancels out and these are cancels out, and the remaining 3x square plus 2 into 3x plus 1 minus 5 will be same as the above expression. So y equal 3x plus 1 whole square minus 1 square means 1, minus 5 minus 1 means minus 6. Up to this is 3x plus 1 whole square, but since I have already minus 5 and we have included minus 1 square, so the extra minus 6 will be here. Now I have said that we need to express x in terms of y, so this minus 6 will be plus 6 if we take it in the left hand side, and then it will be like this: y plus 6 equal 3x plus 1 whole square. Again, if we take under root on both sides, then we will get because if we take under root of this expression, then under root and 2 cancels out, because under root means nothing but this expression to the power 1 by 2. So 2 into 1 by 2 cancels out. The remaining expression will be 3x plus 1. Now we need x only. Therefore, root over y plus 6 minus 1 equal 3x. It will be right. So next, in the next, x will be 1 by 3 of this expression, root over y plus 6 minus 1. So when y equal 9x square plus 6x minus 5, if we convert x in terms of y, then finally we got x equal 1 by 3 whole bracket root over y plus 6 minus 1. Now this x belongs to, so x belongs to, so for x belongs to the closed open interval 0 to infinity, for y belongs to, here if we take y equal minus 5, then what it will be? Then 6 minus 5 is nothing but 1. 1 minus 1 is 0, and 0 by 3 is 0. So the y belongs to the interval minus 5, close interval minus 5 to open interval infinity. So since we have got this expression of x, I can directly say that this will be belonging to this interval if we take y in this interval. So we can directly say that this function f is onto. Therefore, f is onto. So since f is both 1 as well as onto, therefore f is a bisective map, and hence it is invertible. Since f is both 1 and onto, therefore it is a bijective map. This is a bijective function. So is invertible. Since f is invertible, therefore f has an inverse and it is nothing but the expression x equals 1 by 3 root over y plus 6 minus 1, right? It was minus 1? Yes. Because by definition of invertible function, if we can show that the function is invertible, then the another function will be the inverse of the first function or the given function. So we have finally found an expression of x equal 1 by 3 of root over y plus 6 minus 1, and this is nothing but another function g of y in terms of y. So f has an inverse, and it is inverse goes from minus 5 to infinity to 0 to infinity, and it is defined as an f inverse of x will be equal to 1 by 3 root over x plus 6 minus 1. So this is the inverse of f. Here we have y plus 6 minus 1. But since I am writing f inverse of x, so if we replace y by x, it does not matter. So our next question is, let a equal set 1, 2, 3, 4, b equal 2, 4, 6, 8. If f is a function from a to b defined by f of x equal twice x, then so that f inverse of inverse is nothing but the function f with this. So we have a function f from a set a to b, and in set a the elements 1, 2, 3 and 4, in b 2, 4, 6, 8. So if we take the help of this figure, it will be very better to understand. So, since f is defined as f of x equal twice x, therefore the element will be like 1 is related to 2, because when x equal 1, f of x will be 2 into 1 and it equals 2. So 1 relates to 4, 3 is going to 6, 4 is going to 8, right? So if we take the help of this figure, this is very clear. From the figure, it is very obvious that this function is 1, 1, right? So this function is 1, 1. Now f is onto also. How? Since the elements in B 2, 4, 6 and 8 have distinct pre-images in the first set A, so B is so the function f is onto also, and there is no other element left behind. Therefore, obviously f is onto also, right? So f is invertible, because we all know that if a function is both one and onto, then it is invertible and the inverse of this function exists. Now we are given f of x equal twice x. Let us take that f of x equal y. Since f is a function from a to b and y is the image of the element x. Now we express x in terms of y, that it will be x equal y by 2. Now there is no need to show that first of all, x is nothing but another function g of y in y, right? We can write x as g of y. So here we have done this. But now, by definition of invertible function, if we are given a function f and to show that this function is invertible, then first of all we find another function z and so that their composite functions are identity, and then we can say that the function which is given in the question is invertible. But we have already showed that this function f is 1, 1 as well as onto, so this is invertible. So this gy equal y by 2, this will be the inverse of this function f, right? So this is nothing but the inverse of f. So f inverse of x equal x by 2. Since we have taken the element x, so we can replace y by x. this is a variable, so we can change it. Since here g of y, in terms of y we have written, so g of y equal y by 2. Since I take f inverse of x, I can write x by 2. So this will be the inverse of f, and it goes from b to a. F inverse goes from b to a. But the question asks to show that f inverse of inverse is f. This is nothing but inverse of the inverse of f equal f itself. So first of all, we have found f inverse of this function f. Now again we will find what will be the inverse of this f inverse. Since f inverse of x equal x by 2, or we can use this, then it will be very easy. We can use this. Since g of y equal y by 2, or we take g of y as x, y by 2. Now we express this y in terms of x, then y will be equal to twice x. Again, we see the f inverse in such figure. So I will show you here. F inverse is a function from b to a. Elements in B are 2, 4, 6, 8, and A contains the element 1, 2, 3, 4. Right? Since f inverse of x equal x by 2, that means the image of this element x will be x by 2. Since f inverse of x equal x by 2, therefore for the element 2, it will be 1. 2 by 2, 1. So this is related to 1. Similarly, 4 by 2, this is 2. 6 by 2, this is 3. 8 by 2, that is 4. So the function will be like this. And again, from this figure, it is very clear that the elements of B, 2, 4, 6, and 8 have distinct images in A. So this is 1, 1. As well as this is on 2 also. Since the function f inverse is 1, 1 as well as on 2, and we have found y equal fx, this will be the inverse of this f inverse. So we take y as f of x equal to 6. Since this f inverse is 1, 1 as well as on 2, I am repeating this because very easy and simple. There is only one thing which is getting repeated. So fx equal to sx will be the inverse of this function f inverse. So fx equal to sx, or f from a to b is the inverse of this function f inverse. So here in this question, to show that f inverse of inverse equal f, as we have found f inverse of this function f, and again find inverse of f inverse, again we have found inverse of f inverse as f. So finally we got, so combining all this, we got f inverse of inverse is nothing but the function f itself. So it is done. Very easy, and I hope it is clear to you. But if you are not getting it, then please pause the video and take a glance again. Then surely you will be getting. So, so that's all about this class. I hope you are enjoying my class. If you have not subscribed to my channel yet, then please do subscribe to my channel. And thanks for watching the video.